So in this video, I'll discuss the valence bond theory. So the valence bond theory describes the covalent bond as number one, sharing of at least a single electron from each atom. So kapag ka nag-share sila ng tig-isang electron, they will form a single bond. Okay, kapag ka naman double bond, dapat tig-dalawa sila ng electrons na i-share. Kasi 2 electrons, 1 bond. Okay? So kapag ka 4 electrons yung sinishare nila, they are forming 2 bonds or a double bond. Okay? So second one, overlap of orbitals. So hindi lang electrons yung sinishare nila, pati orbitals. So the overlap of orbitals follows a mathematical approach called the linear combination. So linear combination of atomic orbitals. So kapag ka nag-linear combination sila, nagpo-form sila ng molecular orbitals. So meron tayong theory discussing molecular orbitals, tapos i-discuss ko siya in the future or in the later videos. Okay? So kapag nag-linear combination na, nag-form na sila ng bond. Tapos doon na nagta-travel yung mga electrons na sinishare nila. Okay? So the earliest representation of the valence bond theory or the bonding in atoms is through the electron dot structures or the Lewis electron dot structures. So according to the Lewis electron dot structures, kapag ka meron kang atom, okay, at meron siyang valence electrons, meron siyang particular set of electrons na ready for sharing, tapos meron naman siyang mga electrons na hindi sinishare kasi sila ay paired na. Okay, so tingnan natin yung mga examples na nandito. So for the group 1, we have hydrogen and lithium. So makikita nyo, since isa lang yung valence electron nila, isa lang yung electron na available for sharing. So sa group 2, okay, we have the beryllium. Okay? So makikita nyo yung electrons ng beryllium ay not paired, hindi paired sa isa't isa yung dalawang electrons niya. So according to the Lewis electron dot structure, yung beryllium ay pwedeng mag-share ng at most 2 electrons. So pwede niyang ibigay yung bawat isang electron niya sa magkaibang atom or pwede rin sa isang atom lang or the same atom. Okay? So sa boron, we have 3 electrons ready for sharing or ready to form covalent bonds with other atoms. Sa carbon, we have 4. Sa nitrogen, pag tinignan nyo yung nitrogen, yung isa niyang pair, okay, ng electrons ay magkasama na. So, hindi na siya available for bonding. Kaya siya white. Okay? So, the green dots represent electrons that are available for sharing. Kapag hindi na siya green, usually hindi na siya sinishare ng atom. So, sa nitrogen, 3 lang yung atoms or yung electrons na available for sharing. Okay? So, sa oxygen, yung 4 niyang electrons ay paired na. So, may 2 kang electron pairs na hindi na sinishare o hindi na nagbaband. Okay? Meron siyang 2 electrons na unpaired. So, ibig sabihin, pwede siyang mag-share ng electrons sa 2 atoms. Okay? So, sa fluorine, yung 3 pairs ng electrons ay hindi na available for sharing. So, yung nag-iisang electron na ito na lang yung kanyang nasi-share. So, for noble gases, wala na siyang electron pairs na available for sharing. Kaya, usually, yung ating mga noble gases ay atomic na lang, kanilang state. Okay, hindi na sila nagkakaroon ng compounds. Okay? So, again, the green dots represent the electrons that are available for sharing. So, also, elements in the same group have the same configuration. So, lahat ng carbon group, lahat ng boron group, pare-pareho sila ng number of valence electrons. Okay? So, ibig sabihin, pare-pareho sila ng Lewis electron dot structures. So, all boron groups, beryllium, lahat ng nasa ilalim ng beryllium, lahat yan ay may 2 electrons ready for sharing. Lahat din ng group 1, ganon. Sa nitrogen, lahat ng nitrogens pare-pareho ng Lewis electron dot structures as well as oxygen group or the chalcogens as well as the halogens. So yung fluorine, chlorine, bromine, lahat sila isa lang yung electrons na usually sinishare nila. Okay? So for example, we will create a compound or represent the compound through the Lewis electron dot structure. So meron tayo for example na ammonia. So yung ammonia, okay? So dito sa part na to, yung green ay not necessarily electrons that are ready for sharing. So, hindi na to sinusunod dito sa part na to. So, ang ginagawa ko na lang dito, sinesegregate ko na lang kung anong electrons yung nasa nitrogen at kung anong electrons yung nasa ibang atom or sa hydrogen. Okay? So, yung mga green, yun yung electrons ni nitrogen. Yung white, yun yung electrons ni hydrogen. Okay? So, nitrogen has 5 valence electrons pero 3 lang doon yung available for sharing. Sa hydrogen, meron siyang tagi-isang electrons na available for sharing. So, a total of 3 hydrogens here. So, makikita natin dito na kapag nag-form yung ammonia, okay, so for each bond, may isang electron from nitrogen at may isang electron from hydrogen. So, ganyan sila nag-share. So, that's how you represent ammonia using the Lewis electron dot structures. Okay? So, another example, yung carbon dioxide. So, again, merong 4 na electrons yung carbon na ready for sharing. Tapos, yung oxygen nyo ay may tig dalawang electrons na ready for sharing. So, each oxygen will donate 2 electrons dun sa carbon. Tapos yung dalawang electrons ng carbon ay magbabond sa isang oxygen. So, ibig sabihin, per carbon-oxygen bond, may dalawa kang bonds. So, double bond yan. Okay? Yeah. So, may dalawa kang double bond sa carbon dioxide between the carbon and the oxygen. Okay? So, another example, sulfur dichloride. So, sa sulfur, okay, meron tayong dalawang electrons ready for sharing. Tapos, yung chlorine natin may tig isang electron na ready for sharing. So, kapag nag-form yung ating sulfur dichloride, meron tayong isang bond, sulfur-chlorine bond, tapos another sulfur-chlorine bond na dalawang single bonds lang. Kasi, tig isa lang sila ng electrons na share. Okay? So before we proceed with the concept of orbital overlap, discuss muna natin yung concept ng nodes ng mga orbitals. Okay? So a node is an empty region, meaning walang electron density and wala ring wave function. So walang electron na nagta-travel sa mga nodes. Okay? So we have two types, radial and angular nodes. So radial nodes are nodes due to the principal quantum number n. So nakadepende yung number of nodes sa distance ng ating electron sa center ng atom. Okay? So as the distance increases, dumadami din daw ang ating radial nodes. So as we can see here, sa 1s orbital, wala tayong radial node. Okay? Sa 2s orbital, meron tayong node. So ito yung ating radial distance, okay? From the center of your atom to the electron of interest sa 2s. So makikita natin na walang electron density sa region na to. So that's called the radial node. Okay? Yung radial node ay independent of the angle. So nakadepende lang siya sa distance. So kapag 3s orbital, meron na siyang dalawang nodes. Okay? So to calculate the number of radial nodes, we have the principal quantum number n minus the azimuthal quantum number L minus 1. So for 1s, okay? So 1s siya, so that's 1 minus 0 minus 1. That's 0, wala siyang radial nodes. For the 2s, that's 2 minus 0 minus 1, that's 1 radial node. Okay? So for the 3s, we have 3 minus 0 minus 1, we have 2 radial nodes. Okay? So now let's proceed to the angular nodes naman. So angular nodes are nodes due to the azimuthal quantum number. So these are nodes that are dependent on the angle. So makikita natin dito, okay, for example, sa s orbital, since walang nagbabago sa electron density ng ating wave function as you go from this angle to 90 degrees, for example. So kapag nag-travel tayo from 0 to 90 degrees, hindi nagbabago yung electron density. So wala tayong angular nodes. However, pag pumunta tayo dun sa p orbital, makakita tayo ng angular node. So that angular node is the horizontal angular node. Okay? So dito, meron tayong electron density, pero pag pumunta tayo dito sa angle na to, nawawala yung electron density. So we have a total of one node for the p orbital, which is equal to its azimuthal quantum number. Okay? So sa L equals 2 naman, the d orbital, meron tayong makikitang dalawang nodes, okay? Intersecting nodes. Walang electron density dyan sa mga regions na yan. So we have two nodes or two angular nodes for the d orbital. For the f orbital, meron tayong L equals 3 kasi tatlo yung ating intersecting nodes. Okay? So sa mga regions na yan, wala tayong makikitang electron density. So we have a total of 3 angular nodes, which is equal to the azimuthal quantum number, which is 3. So therefore, the number of angular nodes for each orbital is just equal to its azimuthal quantum number. Okay? So therefore, for a certain orbital, the total number of nodes is equal to n minus 1. Okay? Kasi yung radial nodes natin n minus L minus 1. Okay? Tapos yung angular nodes natin L. Kapag in-add mo yan, okay, magiging n minus 1. Okay? So that's how you calculate the total number of nodes. Kapag ka radial node, n minus L minus 1. Kapag angular node, it's just equal to L. Okay? So now let's proceed to orbital overlap. So kapag ka may orbital overlap, ibig sabihin nun, meron tayong constructive interference between orbitals that are in phase. So constructive interference, ibig sabihin nun, yung mga wave functions natin ay nag-a-add. Okay? So nag-i-increase yung kanilang amplitudes. Okay? Kapag ka naman destructive interference, okay, halimbawa ganito, nagka-cancel naman yung kanilang wave functions. So nawawala yung amplitude, nagiging 0. Okay? So there are types of orbital overlaps. So yung una ay yung sigma overlap or yung tinatawag nating sigma bond. Okay? So sa sigma bond, yung orbital overlap nyo ay head-on. Okay? So wala tayong nodes along the internuclear line. So the internuclear line is the line connecting the two nuclei of your atoms. So ito yun. For example, sa ating sigma bond between the s orbitals, that's the internuclear line. wala kayong makikitang nodes whatsoever doon sa ating sigma bond. Okay? So at least between the internuclear line. So dito naman sa bonding between the s and the p orbital along the internuclear line, wala tayong makikitang nodes. Okay? So that's a sigma bond between the s and the p orbital. So between p orbitals, meron din tayong sigma bonding. So wala rin siyang nodes whatsoever. Okay? So that's the sigma overlap or the sigma bonding. Walang node along the internuclear line. Okay? So again, nodes are regions or areas with zero electron density or walang electron na nagta-travel. Okay? So kapag ka may node, ibig sabihin walang wave function doon or walang electron na nagre-reside sa area na yon or sa region na yon. Okay? So all orbitals can exhibit sigma bonding. So next we have the pi overlap or the so-called pi bond, or this one, pi bond din yan. This pi is Greek, okay? So pi bond means sideways overlap. So magkakaroon ka ng isang nodal plane. So the nodal plane is the plane that you can draw along the internuclear line na walang wave function or walang electron na nagta-travel. So makikita nyo dito kapag ka nagkaroon ng pi bond between 2p orbitals, pwede kayo mag-drawing ng plane na walang dinadaan ng wave function or electron density. So that's a nodal plane. And that nodal plane is along the internuclear line, which is here. Okay? So that's a pi bond. So pwedeng mag-pi bond ang dalawang p orbitals, pwede ring mag-pi bond ang p orbital at d orbital. So makakita kayo ng region na walang electron density along the internuclear line. Pwede ring mag-pi bond yung dalawang d orbitals. Okay? So only s orbitals cannot exhibit a pi overlap kasi kapag s orbital wala tayong node na angular. Kasi angular nodes ang ating key para makapag-exhibit ng pi bonding. So walang angular nodes ang ating mga s orbitals. So hindi sila makapag-exhibit ng pi bonding. Okay? So this is the valence bond theory. Pero may mga problems pa din sa valence bond theory. Okay? So ano yung mga problems na yun? Number one, it does not account for the resulting geometry of the molecule. Medyo mahirap i-imagine yung geometry using the Lewis electron dot structure. So kailangan natin ng isa pang theory to exhibit the geometry of the resulting molecule. So that's the valence shell electron pair repulsion theory. So i-discuss ko to sa susunod na video. So it can also be resolved partly through the so-called orbital hybridization. So ito pa yung isa kong discussion sa susunod na video. Okay? Tapos may isa pang problem. It does not account for the symmetry of the orbital overlap. So hindi basta-basta ang orbital overlap kasi may mga tinatawag na parity ang ating okay? Parity ang ating mga orbitals. Meron tayong mga orbitals na in phase ang kanilang overlap, tapos meron ding out of phase. So sa valence bond theory, hindi pa pinapakita dito yung out of phase na overlap. Paano kaya naapektuhan ng symmetry ng orbital yung magiging resulting overlap? Okay? So nare-resolve siya actually ng molecular orbital theory, which again, i-discuss ko sa susunod na video. So sa mga susunod na video, magdi-discuss ako ng iba pang mga bonding theories. So see you next video.